It's good to be back with you guys. We are on a roll. We are exploring what OCP can do with the community, basically working better together. That's the theme for several sessions we have today. I'm Siamak Tavallaei. I'm involved with the server project. I serve as the incubation committee lead for server project. We've been involved around several sub-projects within server project. One of them is DCMHS. You have seen a number of presentations on that already. DCMHS today has covered a particular use case, and today with Art, we're going to, with Paul actually, we're going to explore new use cases. Paul, please.
Yeah, my name's Paul Artman. I've been working on DCMH for 6 months or so fairly new. I worked on OCP, NIC before, and several other OCP projects. I'm with AMD, and we're going to talk about looking at maybe a wider form factor that is more optimized for some of the hyperscale use cases today. So myself, Paul Artman, Andrew Junkins also helped on this, and also Mike Branch. So just kind of other people have been working on this. I'm not going to spend a lot of time on this because we've talked a lot about the DCMH today, but we're looking at different ingredients. The one we're really talking about today is the HBM form factor. So today we have the FLW and the DNO, and we're looking at what will we do differently as we go forward with the DCMHS spec. So the reason that we're kind of looking at this is the traditional 19-inch form factor is fairly constrained relative to a OU form factor in space.
Yeah, let's just set the stage a little bit.
Yep.
A lot of good people from multiple companies got together and came up with use cases of interest with the highest potential adoption rate and volume. And it was necessary to target a particular rack and form factor, and 19-inch EIA form factor was a very reasonable one. And people agreed that 1U was a reasonable form factor in a 19-inch rack. So the optimization that we have today for DCMHS 1.0 spec, you have recognized it goes after density optimized and a full width that are optimized for 1U, but they do support 2U as well. So that's this optimization point we have today. But then,
and I would say too that nothing precludes using the FLW in a OU rack.
Correct.
Just your stranding space. So as we look at the OU rack, it is quite a bit bigger in terms of capability, which allows you to do wider memory spacing. You know, memory cooling is something that I am concerned about as you talk about MRDIMM and some of these high power technologies. Maybe a little more increased feature set with that extra volume. And different compute complexes. It gives just a little bit more space to work with. I like the 2U myself for air cooling. That's my background. So having a lot more volume to have heatsink and kind of pushing up the TDP. You know, we're continue to go on this kind of linear gen-to-gen increase in CPU power. So having an extra 2U is really useful. When you look at ORV3 versus enterprise, they're very different in terms of power approach. Enterprise is traditional power supply directly plugging into a 1U or 2U. That's very cost optimized. But when we look at ORV3, it's really going to a bus bar approach. And as we look at a kind of different form factor, we think that's more optimized for cost. If we're designed for it, you could retrofit a full width board with a ORV through cabling other mechanisms, but it's adding cost. And then it gives us a little more degree about how we're breaking out the I/O. It's pretty challenging to break the I/O out in some of these form factors in terms of getting all the connectors out there in a tight form factor.
Right. An enterprise data center requires the system itself, the chassis itself, to be fault tolerant and redundant. Within a larger data center, fault tolerance and reliability is very important. But some of the aspects of fault tolerance can be done at a rack level or at a data center level. So that's one of the reasons that some of the requirements are slightly different. 19-inch is a very good environment. 1U is a very good environment. But today we're going to also explore what happens if we have a little bit more width and a little bit more height. What can we do with that?
So again, we're starting with a different paradigm of trying to optimize this for the V3 rack that just came out recently. Looking at a 48 volt DC, and I'm using quotes because there is a range on the voltage to power delivery. And then I think a real point of discussion is, are we 48 volt all the way through, or are we 12 volt, or what is the power scheme going forward? And then one of the big things we need to kind of investigate is the DC-SCM 2.0. So we talked about that earlier about form factors. What is the right approach? Is it there are vertical and there are horizontal form factors for the DCM? So what is the right form factor when we look at something that's different than today? We also Siamak talked about the smart NIC. We think that's something very interesting, and how do we tackle that? It's very challenging to fit on an OCP network today. So what is the right form factor to get that in there that kind of drives more commonality? And having the 2U, I kind of mentioned it, but the 2U does give you a little bit more capability to do air cooling. So you have more air for your fins, for your fin stack, as well having more air for your fans. It does, and if you want to drive density, it doesn't preclude from putting a 1U in there. And you know, if you're putting top of bin, maybe it requires liquid cooling, but there is that trade-off that you get into. But there is still a large propensity for air cooling as far as we can go with it. And then CXL memory, as we look at CXL memory and the different form factors, I think having a 2U capable gives you a little bit more options in terms of those different form factors you could support. So this is a really interesting slide that we put together just to kind of show you the volume approach. So you're looking at an ORV3 chassis. And what you see is when we look at the full width and we have cutouts for the power supply, and we have where the DC-SCM and OCP NIC go, when you go to the full length width, you can get quite a bit more area. So we're looking at capturing up to 50% more area. So we think that's really critical as we kind of scale out our roadmaps going forward.
One important factor that I have to mention here is when we have more resources, it's not there for us to waste it. We want to use it fully. So if we have more space, we want to put more devices on it, more DIMMs, more processors, more something. We will use it all.
Yeah, and it doesn't mean that you have to be that wide, but we want to grab the real estate and make sure we have that space going forward.
Right.
And I do like the capability that we've added with ORV3 for liquid cooling. So you do have the possibility of putting a manifold in there. How do you bring liquid into your server also? And then that 48 volt gives us a lot of power input capability to the server.
This diagram is also showing the notches for the power supplies, the redundant power supplies. Again, that is important for an enterprise deployment of these servers. 1+1 redundant power supplies is what normally people do in data centers, in enterprise data centers, or even edge data centers. But within the hyperscale data centers, more than likely, power redundancy is done outside of the chassis within a rack. And therefore, one input power is enough. Because of that, then we could maybe remove those notches, either remove the whole thing or use them for board space.
So kind of the call to action is this is preliminary. It's something we're looking at a DCMHS work group to add. It's not added today, but we're looking, for people interested in participating in this as part of the DCMHS work stream, really looking for, as Siamak, as I mentioned in the previous one, feedback. What do you see as a need? What we don't want to do is design something that has a little limited acceptance and doesn't drive a volume, because that really doesn't help us all. So any kind of feedback in terms of the form factor features, I think that's really critical, in particular around the breakout of the connectors. That's the thing that's going to drive a lot of this.
One major point to highlight is there are two parameters here, width and height. So maybe we can discuss why we might need bigger width, but the question is, do you also need 2U? Could everything be 1U? Again, optimization can be around 2U, but we will have solutions for 1U as well. Now, that is a little bit of a pivot point that we need to consider, and looking for feedback from others. You have seen DC-SCM 2.0 mechanical proposals and it's close to be approved in a vertical form factor. So horizontal form factor we have seen optimized for 1U, but some companies who would like to have the freedom on the I/O section to change it, configure it however they like to, and they're okay with 2U form factors. They plug in DC-SCM and SmartNIC in a vertical form factor, and the rest of the chassis, rest of the front side of the chassis is available for varying I/O. Could be GPUs, could be storage elements, could be CXL. We should be considering that CXL is going to be prevalent by the time we are done with all of these concepts. CXL solutions will be out there. We want to use them for memory, accelerators, or storage devices. We will need more. We will need more because Paul could maybe help me out here. Processors, because he builds processors.
Yeah.
Processors are giving us more and more cores. With more and more cores, you get multiple effects. You need more memory. If you need more memory, you need more memory channels. You have more memory channels, you need more space. How do you take advantage of that? It could be directly connected with many more I/O coming from the processors, or it could be remotely connected through CXL for more memory. Nevertheless, we need more space. So if we go to a 2U, we could also provide larger fans. Larger fans are normally more efficient in moving air compared to smaller 1U fans. So efficiency on moving air is important. Of course, if you do liquid cooling by then, 2 years, 3 years time, you will not need a 2U. But for air cooling, it does make sense for us to use a 2U chassis.
Yeah, and I think that the really critical point that we have is that 1U, 2U contrast and what the form factors are. You know, is it a vertical versus horizontal? It's going to make it for the DCSM, for the SmartNIC, for the CXL. What is the right form factors? With cabling, it's easy to support either one, but what's cost optimized? What's the right solution?
Right. For example, you can go on the show floor here, or if you have participated in the Flash Memory Summit, you see that a lot of people are using EDSFF,
E3.
E3.S, for example, as small form factor modules that are kind of designed for 2U envelopes. You can put them in a horizontal way as well, but they're optimized for 2U envelopes. It's possible that more of the same will be produced. You guys perhaps know your market areas that you're targeting. You can see if the 2U makes more sense or 1U. Basically, what is I/O of tomorrow? Is I/O of tomorrow memory, storage, networking devices, or GPUs or accelerators? And therefore, how much of an I/O space do you need for every processor? For every processor that has many cores, what type of elements you need outside? So for all of those considerations, we believe in addition to a 1U optimization, we do need a 2U optimization. So that's why in this concept proposal, we are thinking to do both at the same time. Go wide and go 2U at the same time instead of having two separate ones. Although if wherever you start, you can do the other one also, but the point is which one is the optimization point to start with.
Should we take some questions?
Yes. Let's
Yeah.
do that.
At the beginning of the deck, you said 2OU, and then you sort of dropped the O partway through the presentation.
Yeah.
You've just been saying 2U, and then you mentioned E3.S, which is 2RU. So I just want to try to get it straight. Are you talking about 2OU or 2RU, or you're not sure?
2OU, optimized for OVR3.
Again, optimization point could be one, and variations could be built as well. For example, it does make sense for us to target a standard chassis. EIA 19-inch is based on RU, but ORV3 is based on OU. So if we are targeting a rack that is Open Rack V3 compliant, so it does make sense for us to start with an OU first, but that if you have an RU, it will fit in there as well. Whatever we do, we need to allow for other cases, because from my point of view, from my company's point of view, hyperscaler, Google point of view, we do things on our own. Whatever it is, we have special form factors for that, for example. But we would like to take advantage of other people's products as well. So we do have programs that strive for receiving off-the-shelf servers. Some people have done a great job. We would like to plug it into our data centers. So for that, we do have programs around standard form factors at the rack level. You probably have attended a presentation on Google version of ORV3 design based on the base spec. So in other words, OU is fine. It's a very good starting point.
Any other questions? Feedback's definitely welcome.
Could you guys come and help us? Join the team. Help us with use cases. Help us with challenges that you have seen. Identify the problems for the team to solve. And now I'm very proud. We have a very strong team of architects, designers, and we've been working together for about a year. As we said earlier during DCMHS presentation, over 60 people from today out of 7 companies, but soon when you guys join, we'll have representation from other companies as part of that team. That's basically the type of team that have been doing this kind of things for many, many generations of servers. They know their stuff. They know all the trade-offs. It's just a matter of weighting factors. Which one is more important this generation? And with DCMHS, we haven't said that this is one solution forever. It's a one solution for a period of time. We define what that is together. 2 years, 3 years time, a particular module gets built. Maybe it is useful for the following generation, but if it is not, we will redo the module in a different form factor. This is OCP. We are free to do whatever we want to do. Hopefully it makes sense, and hopefully it receives enough feedback for it to be useful for others, and therefore be adopted and put to work.